Hello students, welcome to Saurav Sir's classes. Today we are going to solve a few questions on differential equations. The question is the problem minus y double dash plus 1 plus x into y is equal to lambda y, where x belongs to the open interval 0, 1 and y0 is equal to y1 is equal to 0 has a non-zero solution. Then option A for all lambda less than 0, option B for all lambda belonging to the closed interval 0, 1, option C for some lambda belonging to the closed interval 2, infinity, and option D for a countable number of lambdas. Now, the given equation is of the type y double dash plus lambda dash y is equal to 0. Now for this we can have three different cases. So the very first case is if lambda minus 1 plus x is equal to 0, then y double dash is equal to 0. This means that y is of the form ax plus b. Applying boundary conditions, we get y is equal to 0. That is the trivial solution. Now case 2, if lambda minus 1 plus x less than 0, then let lambda minus 1 plus x is equal to minus t square. The given equation becomes y double dash minus t square y is equal to 0. Then its solution is y is equal to c1 e to the power t plus c2 e to the power minus t. This is because from this we get the auxiliary equation as m square minus t square is equal to 0. That is m minus t into m plus t is equal to 0. So m is equal to t or minus t. Now once we get this y, after applying the boundary conditions, we get the trivial solution y is equal to 0 as the only solution. And case 3, I don't have much space over here at the bottom, so I would be doing at the top. So case 3, if lambda minus 1 plus x greater than 0, then lambda minus 1 plus x is equal to t square. Let this be our supposition. Then the equation becomes y double dash plus t square y is equal to 0. Now once you take the auxiliary equation of this, that is m square plus t square is equal to 0, or m square is equal to minus t square, and from here you'll get m is equal to plus minus it, where I is equal to root over minus 1. Then its solution would be y is equal to c1 cos tx plus c2 sin tx. Further, y0 is equal to 0 implies c1 is equal to 0 and y1 is equal to 0 implies sin t is equal to 0, which further implies that t is equal to n pi or lambda is equal to n square into pi square, where n belongs to natural numbers. Therefore, there exists a non-zero solution for lambda belonging to 2, infinity. Moreover, for countable number of lambdas, as natural numbers are countable, the solution exists. Therefore, option C and option D give us the correct answers.